Hello guys, welcome to my channel. In this video we will see the method of least squares. Introduction. In engineering, two types of application are encountered. The first one is trend analysis. Predicting values of dependent variable may include extrapolation beyond data points or interpolation between data points. The second one is hypothesis testing, comparing existing mathematical model with measured data. Curve fitting. There are two general approaches for curve fitting. The first one is least square regression. Data exhibit a significant degree of scatter. The strategy is to derive a single curve that represents the general trend of the data. The second one is interpolation. Data is very precious. The strategy is to pass a curve or a series of curves through each of the points. Working procedure. To fit the straight line y equals a plus bx, substitute the observed set of n values in this equation. Form the normal equations for each constant, that is summation y equals na plus b summation x, summation xy equals a summation x plus b summation x square. Solve these normal equations as simultaneous equation of a and b. Substitute the values of a and b in y equals a plus bx, which is the required line of best fit. To fit the parabola y equals a plus bx plus cx square, form the normal equations summation y equals na plus b summation x plus c summation x square, summation xy equals a summation x plus b summation x square plus c summation x cube, and summation x square y equals a summation x square plus b summation x cube plus c summation x to the power 4. Solve these as simultaneous equation for ABC. Substitute the values of ABC in y equals a plus bx plus cx square, which is the required parabola of the best fit. In general, the curve y equals a plus bx plus cx square plus k x to the power m minus 1 can be fitted to given data by writing m normal equations. The normal equation for the unknown a is obtained by multiplying the equations by coefficient of a and adding. The normal equation for b is obtained by multiplying the equations by the coefficients of b and adding. The normal equation for c has been obtained by multiplying the equations by the coefficients of c and adding. Here one example of straight line. Fit a straight line to the x and y values in the following table. First we write the x and y values and adding the values, and the next we can multiply the x and y values and square the x values, and the values of x is 28, y is 24, and x square is 140. X and y equals 119.5. We can find x bar equals x divided by n. N is the total number of values in the table, and y bar equals y divided by n. We have the values of x bar and y bar. This is the formula to find a1. N summation x1 y1 minus summation x1 summation y1 divided by n summation x1 square minus summation x1 whole square. We can substitute the values according to this formula, and we find a naught equals y bar minus a1 into x bar, and substitute the values according to this formula, we get y values. Here are some applications of least square method. The most important application is data fitting. The best fit in the least square sense minimizes the sum of squared residuals, residuals being the difference between an observed value and the fitted value provided by a model. The second one is when the problem has sustainable uncertainties in the independent variables, the simple regression and least squares methods have problems in such cases. The methodology required for fitting errors in variables models may be considered instead of that for the least squares. If you like the video, please like, share and subscribe to my channel. Thank you.